assignment in physics.
Yes, me too. It was very hard.
Oh my god. You have an assignment?
You don't know?
No.
Why?
Do you know someone or something that could help us?
I know, guys. Basic. The YouTube. The enlightenment.
Oh. You think that will help us?
Yes. Paterno Academy will help us.
I haven't heard that. Me too.
We'll see. Oh, next here.
Welcome to Paterna Academy. Today, I will now discuss you the topic equilibrium. Equilibrium occurs when an object has zero acceleration or constant velocity. For example, this banana. This banana is not moving. Therefore, it is in equilibrium. There are many forces in a system that can affect the equilibrium. The equation for equilibrium is summation of all forces acting on an object is equals to zero.
So now, here we go. Free body diagram is a graphical illustration used to show the relative magnitude and direction of all forces acting upon an object in a given situation. For example, an object is placed on a horizontal surface, and the forces acting on it are the weight, which is directly downward, and the normal force, which is perpendicular to the horizontal surface. Since there are no forces acting horizontally, the summation of Fx is equals to 0. On the other hand, the summation of Fy is equals to 0 is represented as normal force minus the weight is equals to 0. Another, an object placed on an inclined plane raised at an angle theta above the horizontal, and the forces acting on it are the weight and the normal force. Now, in order for us to fully understand the problem, we have to rotate its axis, and it will be like this. This will be the normal force and the weight. Since we have an angle, the weight has its component x and y. Therefore, the summation of Fx is equals to 0 will be represented as W sine theta is equals to 0. While the summation of Fy is equals to 0 is represented as the normal force minus weight cosine of theta is equals to 0. After Maya's mother hanged a 2 kilogram pair of soaked jeans in a 3-meter clothesline, it sagged in 0.5 meters. How much force is exerted in the clothesline? First, we have to draw the problem. As you can see, the clothesline is 3 meters, and after hanging the pair of jeans, it sagged in 0.5 meters. For us to solve the problem, we have to draw the free body diagram. The forces acting on it are the weight and the tension, T1 and T2. First, we have to get the theta. Using the trigonometric functions given the 0.5 meters and the 3 meters, we will be able to solve this. Using tan theta is equals to opposite over adjacent, we can now get the theta, which is 18.43 degrees. After getting the theta, we can now solve the problem using the concept equilibrium, which is the summation of Fx is equals to 0. And it represents as T1 cos theta is equals to T2 cos theta is equals to 0. We could just solve using the substitution of the values. On the other hand, we have the summation of Fy is equals to 0. which is T1 sine theta plus T2 sine theta minus W is equals to 0. T1 sine theta times 18.43 plus T2 sine theta 18.43 minus 2 times 9.81 is equals to 0. We could get the tension using the system of equations, and we could just plug into that in our calculator. And we could get these answers. T1 is equals to 31.03 newtons and T2 is equals to 31.03 newtons. They're just equals because the cable is just 1. Always bear in mind, arrowheads must be present because these are vector quantities. Second, the orientation of signs must also be considered since vectors must have proper directions. And lastly, since we are in equilibrium state, always equate the equation to 0. That's all. Thank you!
Oh! That's how.
Now we can do more problems about equilibrium. And we can use that in application.
What do you mean by that?
Maybe we can find something around here.
Oh!
How about this TV? What kind of forces act on this TV?
There are two forces acting on that TV.
What? What are those?
The weight and the normal force.
Okay. The weight and the normal force.